Section 3.1, Functions and Function Notation. A function is a relation in which each possible input value leads to exactly one output value. We say the output is a function of the input. Okay, and function notation here. The input values make up the domain, and the output values make up the range. Now this statement, the output is a function of the input, we often will write this as y equals f of x to indicate that y values are our outputs and x values are our inputs. So the output is a function of, that's how these two are related, of our inputs. Now, with this coffee shop menu, the first question is price a function of the item? That is, items are our input and price is our output. So does every item have a unique, that's where this exactly one, does every item have a unique price? And if we look at each one of those, plain donuts, $1.49, they have their own price. Jelly donuts have their own price. Chocolate donuts have their own price. So yes. All right, every item has a unique price. In the other direction, is the item a function of the price? That is, our price is our input and the item is our output. So, in this case, does every price have its own item? So the two prices we have here are $1.49 and $1.99. $1.49 has an item that uniquely is assigned to it. However, $1.99 does not. There are two different items with that same price. So no. $1.99 has no unique item. Alright, same idea, example 2. In a particular math class, the overall percent grade corresponds to a grade point average. Is grade point average a function of the percent grade? And vice versa, is the percent grade a function of grade point average? This table shows a possible rule. So the first question is, does percent grade have a unique grade point average? So if I gave you a percent grade, say a 67, that has a grade point average of 2.0. If I take any other value, 79, it has one, it's 3.0. So for the first question, yes. So we have, all right, let's see, grade. In fact, I'm going to write this as percent grade has a unique GPA. So yes. The other direction, does GPA have a unique grade or percent grade? In this case, if I take something like 1.5, there are actually, what is that, 5 values? 62, 3, 4, 5, and 6. There are 5 different values. So this does not. So the order that you have inputs and outputs matters. So let's use function notation next to represent a function whose input is the name of a month and the output is the number of days in that month. I'm going to write that using our function notation as my output is a function of my input. D equals f of m. So a couple of examples. I'm not going to write this out for all 12 months, but we could say something like f of January. January has 31 days in it. So f of January equals 31. F of February, and that one's a little trickier because If we're not a leap year, then it has 28 days. So we're going to assume it's not a leap year. F of March would be 31 days, etc. So we would do that all the way to F of December. And December has 31 days. Now, of course, they have varied. Some of these months have 30 days as well. Example 4, a function n equals f of y gives the number of police officers in a town in year y. What does f of 2005 equals 300 represent? Well, that means in the year 2005, there were 300 officers. 300 officers in that particular year. Example 5. Which table represents a function, if any? So we have inputs and outputs. And the idea is that every input has a unique output. So let's consider each of the inputs. For the first table, we have 2. 2 has a unique output of 1. 5 only has one output, and 8 only has one output. So this is a function. All right, the next table, -3 has only one output, 0 only has one output, and so does 4. So this one is also a function. Now the last one, we have 2 inputs here actually. We have 1 and 5. 1 has a unique output, however 5 has 2 outputs. So I'm going to actually ignore that one right there. 5 has 2 outputs, which means this is not a function. All right. A very basic way of understanding this, which a lot of people have learned, is that if it's a function, the x's do not repeat. And that is true. Our x values cannot have 2 outputs, therefore they don't repeat in some sense. All right, example 6. Find each of the following based on this function. F of x equals x squared plus 3x minus 4. So we're going to find f of 2. F of 2 is going to be x squared, so 2 squared plus 3. In this case, our x is 2. Minus 4. So that is 4 plus 6 minus 4. So this means that f of 2 equals 6. When our input is 2, our output is 6. All right, next we want to find f of a. This one's a little bit easier because our input is a, so this means a squared plus 3a minus 4. And there's nothing we can do to simplify that. Okay, we have different powers of a, so those terms cannot combine, and that's f of a. Next we want to find f of a plus h. Okay, our input is a plus h, so this will be a plus h squared plus 3, a plus h, minus 4. Right, now, a plus h squared is a plus h times a plus h. So this is going to be a squared plus 2ah plus h squared sure that's clear. I'm going to distribute here and make that 3a plus 3h minus 4. Combining like terms, we have a squared. Actually, there are no terms to combine. That's it. Okay. We'll go ahead and write that anyways. A squared plus 2 AH plus H squared plus 3A plus 3H minus 4. That is f of A plus H. Okay. Now for part D, we're finding f of A plus H minus f of A divided by H. Now this is actually a concept related to calculus. What we're doing is we're finding the slope actually. It's hard to see here, but that's what's going on. So f of A plus H, we're going to replace each of these. A squared plus 2AH plus H squared plus 3A plus 3H minus 4 minus f of A, which is A squared plus 3A minus 4. All of that divided by H. All right, now if we distribute the negative on the second half of that and then combine like terms, a few terms cancel out. Our A squared terms cancel out. Okay, A squared minus A squared. We have 3A minus 3A. And we have negative 4 minus negative 4. So what we have left is 2AH plus H squared plus 3H divided by H. Now factoring out an H in the numerator gives us 2A plus H plus 3 and divided by H. Those H terms simplify, leaving us 2A plus H plus 3. For example 7, given this function, evaluate H of 4. All right. That is our input. So everywhere we see a P, we are going to replace that with a 4. So 4 squared plus 2 times 4, which is 16 plus 8. All right, so H of 4 equals 24. Next, we're going the opposite direction. Given the function h of p equals p squared plus 2p, solve for h of p equals 3. So we want to know when the output is going to be 3. So our output, 3, equals p squared plus 2p. We'll solve this as a quadratic. Subtracting 3 from both sides gives us p squared plus 2p. Minus 3 equals 0. Okay. Now that quadratic factors as p plus 3 times p minus 1, that equals 0, which leads us to the fact that p plus 3 equals 0, or p minus 1 equals 0. So p equals negative 3, or positive 1. Number 9, example 9, express the relationship 2n plus 6p equals 12 as a function of p equals f of n. So we want this written in a way where we have p equals and then a function in n. So let's solve this for p. We'll subtract 2n from both sides. That would be 6p equals 12 minus 2n. And then we will divide both sides by 6. So p equals 2 minus 1/3 n, where f of n is 2 minus 1/3 n, so that works out just fine. If you notice, this is linear. Okay, linear functions, we call them linear functions for a reason, other than the vertical line. Those are functions, so we can write them using function notation. Not every equation can be written that way, however. Example 10, this is a good example of that. Does the equation x squared plus y squared equals 1 represent a function with x as the input and y as the output? If so, express the relationship as a function y equals f of x. If we were to solve this for x, or for y, as our output, we end up with a square root. We'd actually have a plus or minus a square root, which would cause us to not have a function. We would have two different outputs for one given input. So how I want to demonstrate that is I want to take 2 points. Okay, consider the point 0, 1 and the point 0, -1. Both of these points satisfy that equation. 0 squared plus 1 squared is 1, so it makes that equation true. And 0 squared plus -1 squared also equals 1. That means that this is not a function, because we have one input value, 0, that gives us two potential output values, 1 and -1. So this is not a function. Okay. Using this table below, answer these questions. Evaluate g of 3. That implies that 3 is our input. From an input of 3, we get an output of 7. So g of 3 equals 7. Now, the second part, solve g of n equals 6. The output is 6, and we want to find the input based on that output. So for that, we have an output here, an output here. This is both 6. The input that matches with each of those is 2 and 4. So n is 2 or 4. So there's with a table. Now let's look at a graph. Given this graph, answer these questions. Evaluate f of 2. Again, that implies that the input is 2. So we're going to start at an input of 2. And we're going to come up here to our graph. Now, what is the y value at that point? That's 1. So f of 2 equals 1. You could write this as the point 2, 1 is part of this graph. For the second part of this, the output is 4. So if I started an output of 4 and I go in both directions, I find 2 points here which have input values of -1 and 3. So x equals -1 or 3. And again, we could write these as we have the points -1, 4, and we have the point 3, 4 as a part of that graph. Now, what we have seen a couple of times now is our inputs often have, as functions, they have to have one unique output. However, our outputs do not always have to have a unique input. As you can see here, we have one output with two different inputs. That is a function. Okay, this graph we have over here is a quadratic. It is a function. However, it is not what we call one-to-one. A one-to-one function is a function in which each output value corresponds to exactly one input value. That means there are no repeated x or y values. So this function that we have there is not one-to-one. Now the question we have here is the area of a circle a function of its radius? And if yes, is it one-to-one? So that would mean, does a value of a radius, give us a unique area? And the answer to that is yes. Okay, so this is a function. Now, is it one-to-one? That would imply the other direction. That would mean that our area gives us a unique radius. And that is also true. So this is a function and it's one-to-one. And to see that, you could actually take the function area equals pi r squared. Let's actually work with that real quick. If I solve this for r, what I get is the square root of area divided by pi. Now, because area is going to have to be positive, I don't need the plus or minus. In fact, my radius is always going to be positive as well, so I don't need a plus or minus on this. So that is my unique radius based on my area. So if I give you a radius, you can certainly tell me without any ambiguity what my area is. And if I tell you the area, you can tell me without any unclearness or ambiguity what the radius is. Okay, next we see something called the vertical line test. The vertical line test tells us that if we can draw a vertical line that intersects a graph more than once, then the graph does not define a function because the function has only one output value for each input value. Okay, so basically drawing a vertical line tells us whether the x's repeat, whether an x value has more than one y value. So let's attempt to draw a vertical line. If we could draw a vertical line that will cross this more than once. No, I'm not seeing anywhere. This is a function. All right. Part B. If you notice, no matter where I draw a vertical line, okay, it's never going to cross that more than once. So that is also a function. Part C. Part C, I can draw a vertical line. In fact, I can draw it anywhere between 3 and negative 3, and it will cross that twice. So this is not a function. Okay, it is not a function because of that. Consider these functions shown above. Okay, we have the a and b are functions. Are these one-to-one? Now this actually brings up something called the horizontal line test. Because drawing a vertical line tells us that every x has a unique output, or every input has a unique output. If we want to know if every output has a unique input, we can cross horizontally instead of vertically. So the horizontal line test tells us if it's one-to-one. All right, so if I take a horizontal line, it'll work just fine on B. Okay, so B is one-to-one. However, A is not. Okay, so I'm going to go ahead and draw this in a different color, but if I draw a horizontal line here, it crosses that graph more than once, so that's not one-to-one. Alright, that brings us to this section on functions and function notation. The horizontal and the vertical line test, keep those straight. Which one tells you one-to-one and which one's a function. Get familiar with function evaluation, and that definition of a function is likely the most important thing, overarching theme really, in all of algebra. So make sure that you understand that definition at the very beginning of this.